Hi, welcome back to the Mathemagic channel. Today we cover one of three essential theorems that have to do with finding factors inside of a number. Now, there's one theorem for product of factors, one theorem for sum of factors, and today we're covering the theorem for the number of factors inside of a number. This is absolutely critical for Math Olympiads, so let's jump right in. So finding the number of factors of a number, well, what does that mean? Prime numbers have two factors, 1 and themselves. So if you think about the number 2, for example, 2 is a factor and 1 is a factor because 2 is prime. If you think of a composite number like the number 4, 4 has 1, 2, and 4, and it has 3 factors. So when we look at the number of factors of a number, that's what we mean. If you look at the number 12, so 12, usually what we could do to figure out how many factors 12 has is we can look at the factor pairs which make up 12. And so for factor pairs, we can start with 1 times 12, and then the next one would be 2 times 6, and the next one will be 3 times 4, and the next one will be 4 times 3. So we've pretty much covered everything, starting with 1 and working our way up. So 12 has 3 factor pairs. And if it's got 3 factor pairs, that means that in total, 12 has 6 factors. And if we put them in order, that is 1, 2, 3, 4, 6, and 12. So if we try another one here, let's look at the number 100. Again, if we look at the factor pairs, we'll have 1 times 100. And if we go up a little bit, 2 times 50. So 2 times 50. 3 is not going to be a factor of 100. 4 is, so we have 4 times 25. And then we'll have 5 times 20. And then there's a bit of an odd one out at the end here with the 10, because 10 is multiplied by itself, so it's like 10 times 10. So that's not really a factor pair, but 10 is definitely a factor of 100. So 100 has 4 factor pairs and then an extra little 10 hanging out here. So we'll say that 100 has 9 factors in total. And if we list them in order, it'll be 1, 2, 4, 5, 10, 20, 25, 50, and 100. And these are all the factors which make up the number 100. Now, what if we look at a bigger number like 1200, which is actually 12 times 100? Well, if you start looking at the factor pairs, you'll notice that you have 1 times 1200, 2 times 600, 3 times 400. Oof, this might take a while. So it's going to take a long time. This is not the best way to do this, and probably we need to find a better method. So is there a better way to find the number of factors contained by a number? And the answer is, of course there is. Now, this is not a theorem that you'll learn at school very often, because it's more geared towards Math Olympiad training and Math Olympiad practice. So if you're a student who's studying for Math Olympiads, or if you're just in general looking for some more information about how to find the number of factors of a number, this is the kind of theorem that you need. So as we use prime factorizations, we can look at the number 12, and inside of the number 12, which is made up of 4 times 3, the prime numbers which make up 12 are going to be 2 and 3. So 2 is going to be 2 squared, which is 4, and then 3. So as we look at 2 squared times 3, we're going to actually, for this formula, use the exponents, and the exponents in mathematics means the powers. And the powers that make up 12 are going to be 2 squared times 3 to the power 1. So don't forget that 3 to the power 1 is 3. It's not 3 to the power 0. So if we just look at the exponents, we'll have a 2 and we'll have a 1. And those numbers are going to be very important for this formula. So here's the formula. We find the prime factorization of a given number. So the prime factorization is what we have here, 2 squared times 3 to the 1, in power form. And then we add 1 to the exponents. So I see that I have a 2 and a 1. And if I add 1 to each, I'll have a 3 and a 2. So this is the important bit. You need to add 1 to each exponent. And then you multiply that result by each other and you get the number of factors. So in this case, if I have the exponent 2 and I add 1 to it, I'll have 3. And I have the exponent 1 and I add 1 to it, I'll have 2. So I'm going to have 3 times 2, which is actually 6. And 6 factors is the number of factors that 12 had. Remember when we listed them earlier, right? So okay, let's try with 100. Now, we did 100 already. We realized that 100 had 9 factors. Now, is this formula going to work? Presumably it will. What is the prime factorization of 100? Okay, well, 100 is made up of 2 and 5. There's not much else going on. It's 10 times 10. So 10 is made up of 2 and 5, and you have two 10s inside of 100. So it's actually a 2, a 5, a 2, and a 5. So it's two 2s and two 5s, right? So this is what makes up 100. Okay, so 2 squared times 5 squared. And you can verify that this is true because 2 squared is 4 and 5 squared is 25. So 4 times 25 is going to give you 100. And so this is the prime factorization of 100. Now, if we look at the formula which we had earlier, what we need to do is to add 1 to the 2 and add 1 to the other 2. So we look at the exponents, and so the exponents are 2 squared and 5 squared. So if I add 1 to each 2, I'm going to get 3 and 3. So I find the prime factorization in power form, I add 1 to each one of the exponents, and then I need to multiply them by each other. So 2 plus 1 times 2 plus 1, again, I'm just looking at the exponents, adding 1, multiplying them by each other, is equal to 3 times 3. And sure enough, 3 times 3 means that we have 9 factors. So now could we try 1200 again? Because 1200 was super annoying, big number. Well, first we would have to be able to find the prime factorization of 1200. And that's not too hard. Consider the fact that we've already done 12 and we've already done 100. So if we say that 1200 is 100 times 12, this is going to be quite useful. So if you remember, 100 was 2 squared times 5 squared, and 12 was 2 squared times 3. So 1200 is going to be 2 squared times 5 squared times 2 squared times 3. And so now we can add the 2's together following exponent rules, and we can say that we have 2 to the power 4. For the 3's, we'll have 3 to the power 1, and then for the 5's, we're going to have 5 squared. Notice I've put the exponents in red for you because if you remember the formula, we're going to take the exponents, we're going to add 1 to each one of them, and then we're going to multiply that by each other. So when you do this kind of work, I would also encourage you first, before you move on, to take a pit stop and say, do I have the prime factorization right? And if you look at 2 to the power 4, it is indeed 16, and this is, if you know your powers of 2, this is quite useful. 2 to the power 5 is 32, 2 cubed is 8, so 2 to the power 4 is in between, it's 16. 3 to the power 1 is 3, and then 5 squared is 5 times 5, which is 25. Now, if you wanted to check this, what you could do is 16 times 3, which is 48, and then 48 times 25, which is 1200. Multiplying a number by 25 is actually not too difficult. What you can do is divide the number by 4. So if you do 48 times 25, you can do 48 divided by 4. That is because a quarter is 0.25. So a little math trick there, which is quite useful. And so indeed 48 divided by 4 is 12, and so this is 1200, and it's good. So we have the prime factorization right. We can move on. Now remember, we use the exponents. So for my exponents, I have a 4, I have a 1, and I have a 2. What do I need to do? I need to add 1 to each one of those. So I'm going to add 1 to the 4, add 1 to the 1, and add 1 to the 2. So using the same formula which we had before, 4 plus 1 is 5, 1 plus 1 is 2, and 2 plus 1 is 3. So I can do 5 times 2 times 3, and 5 times 2 is 10, 10 times 3 is 30. So I'll have 30 factors. So in this prime factorization, 1200 actually contains 30 factors. And earlier we found the first 6. We did 1 times 1200, 2 times 600, 3 times 400. There's a lot more. So there's another 24 factors going. But you don't need to list them because this formula just gives you the number of factors immediately. Now perhaps this is a good time to practice. So maybe you can pause the video and see if you can figure out how many factors 48 has. Assuming you've done that, what is the prime factorization of 48? Well, 48 is 16 times 3. Again, it's useful to know your powers of 2 because if you see that there's a 16 in there, you'll realize that there's 2 to the power 4 in there. So 48 being 16 times 3, it is 2 to the power 4 times 3 to the power 1. Notice that we put the exponents in red so that we know that that's what we're looking for. And so remembering our formula, we need to take the exponents, add 1 to them, so 4 plus 1 and 1 plus 1, and then multiply that by each other. So we use the exponents, and again we use the same formula. 4 plus 1 times 1 plus 1, which is going to be 5 times 2, and we expect to have 10 factors. Now 48 is a little bit more of a friendly number, so we could actually check that this is true. We can do 1 times 48, 2 times 24, 3 times 16, 4 times 12, and then 6 times 8, and then the next one would be 8 times 6. So we actually have 5 pairs here, and 5 pairs is going to be equal exactly to 10 factors. Thank you for watching this video. Make sure to like and subscribe so that you can support the Mathemagic channel and that we can bring you more math content to help you in your studies and in your Math Olympiad training. Remember, math comes easy with Mathemagic, and see you on the next one.